Alright, so a few more chapters to the end of Form 4. Now we're going to look at Chapter 9, Solution of Triangle. Alright, so solution of triangle, we're going to be looking into four things. Firstly being the sine rule, just going to see the situations and what the formula is. And then we're going to be looking into ambiguous case. Basically this one is just going to involve a few drawings, it's a quite interesting one. And then we're going to be looking into cosine rule, another formula for certain situations, and then the area of a triangle, where we'll be seeing two different formulas. It's new ones. Alright, so firstly, sine rule. So usually sine rule will be written as this. So let's just write it down. Sine rule is basically when A over sine A will equal to, it's supposed to be capital A. A sine A equals to B sine B equals to C sine C. So basically, the sine rule is actually interchangeable. That means that you can also write this as the sine A at the top actually. So A sine A, that's basically the opposite of everything on the bottom. Instead, everything's at the top, referring to the sine, of course. And so basically you would want to use this when you want to find the length of a certain side. So what I mean is, let's say you've been given a triangle over here, right? Okay, let's say you've been given a triangle and they tell you that this is A, B, and C, right? Okay, so let's say they're given that this angle is 20 degrees, and then they actually tell you that this side is, let's say, 2 centimeters, but over here is 5 centimeters. So basically with this information we could actually find the angle of BAC, or in this case just angle A. So it's actually based on the situation. Like let's say that they've given this angle as like 40, right? Like for example, but they don't give you the length of AC over here. So you could just use the sine equation with the 5 over here, and then just use the 40 over there. So let's use this as an example. I want to find the length B over here. So usually what you do is, if you wanted to find the side, you put the side on the top. But if you wanted to find the angle, you put the angle at the top. So in this case, right now, the side is at the top. So that means I would do it as B over sine 20, because, will equal to 5 over sine 40. So that means B will be equal to sine 20 times 5 over sine 40. So if I punch this into the calculator, 5 divided by sine 40 times sine 20, I would get 2.6604 centimeter. Always give your answers in 4 decimal places. But basically, the situations, I'll just be repeating the situations that you should use sine rule, is when let's say they give you a triangle, and then they give you one angle and two sides, and then they ask you for this other angle. Or let's say another triangle, they give you two angles and only one side. That means you have to find this one over here. You have to find the other side. But by right, once you find two sides and two angles, you can actually find the third side, because 180 minus B minus A, you will get C. You use the sine rule again, and then you will get your C length over here. But that is basically sine rule. Alright, now we're going to be looking into ambiguous case. So ambiguous case is basically when there are two different triangles that can be formed. So usually this question is when they tell you to draw a triangle which has an ambiguous case. They will usually state it out loud. So you basically have to draw two triangles using the same length. So you know that this will be an ambiguous case. So this is basically what I found, because usually most questions are usually the same. They will usually just give you two sides. So I usually label them as like A and B. and then they give you one acute non-included angle. So when I say non-acute included angle, that means, let's say you have like A, B, C over here, okay? That means when it's side A and side B, that means if it's a non-acute included angle, that means it's not in between A and B. So it's not this. It's actually the one over here and over here. Either one. So it could be the angle B, or it could be the angle A. So that's based on the question. Alright? Now the other thing is that the acute non-included angle is opposite to the shorter side. That means, let's say I were to draw a triangle. Okay? So that means that, let's say they gave A and B, right? So we know that A is the shorter side, right? It's shorter than B. And then they give you angle A over here. So if angle A over here is opposite to the A, which is the shorter side, then you already know it's an ambiguous case, because by right, you can actually pull this A over here and it will still give you a different triangle. Alright, so let's see an example question. So example time. So the example. Now then, let's say you've been given that side A equals to 3 centimeters, side B equals to 9 centimeters, and they give you angle A is equal to 30 degrees. Now, so we already know that they've already given us two sides, and they've given us the opposite angle, the opposite non-included angle, 30 degrees over here, is opposite to the shorter side, which is the 3 centimeters over here, right? So, when you want to draw this triangle, what you want to do is, usually they might ask you to use a scale, but usually we draw with a general ruler. But in this case, I'm just going to sketch it out right now. Alright, so let's say I label over here as A, over here as B, and over here as C. Now, what you want to make sure is that A, the small a, right, being the 3 centimeters, is on the shorter side, which is the CB over here, right? So this is the A equals to 3 centimeters. Now, and then we know that 30 degrees will be over here, right? So now, when you want to know where to place B, right, the 9 centimeters, you basically have to check the triangle, whether it's AC over here or AB over here. Basically, when you want to do ambiguous case, you do not disturb that longest side. So we already know that B is actually going to be the AC over here, which is shorter than AB. Okay, so B equals 9 centimeters, which is AC, right? So ambiguous case is very simple. You just take the CB over here and draw a second version over here, because by right, this length is the same that it could actually be drawn twice. Alright, so the only way the ambiguous case doesn't happen is if angle ACB, right, angle ACB, it can't equal to 90 degrees. Because if it's 90 degrees, it can't have an ambiguous case, because it would be like perpendicular, right? But if it's it's an acute angle, it can basically be an acute angle or an obtuse angle. It can be both, okay? So yes, when you want to draw the answer, you basically have to draw both. So you have to draw something like this. Alright, so that would be the first case. And then, yeah, so basically this is the... So basically you just draw this. Yes, you can just draw this as the first case. Alright, let me just draw it at the front instead. This as the first case, and this being the second case. So that's how you do ambiguous case. You basically, CB is the one that can be changed. You know, it can move. Alright, and AB, because the fact that they didn't give you side C, that means side C is not, it's not constant. It can be shorter or it can be longer. Alright, as long as B is still 9 cm, A is still 3 cm, and angle A is still 30 degrees. That's how ambiguous case works. Alright, now we're going to be looking into cosine rule. So basically, cosine rule is written like this, right? So cosine rule is when a squared equals to b squared plus c squared minus 2bc cos a. So what's happening over here is that a squared over here is the same thing as b squared plus c squared minus 2bc cos A. So basically, to find this one side over here, you would have to use all three things over here. Now, I'll show certain situations which you have to use cosine rule, because right now you don't see the necessity of it, right? Since we have sine rule from just now. But basically, this formula can be manipulated in the other three ways, as in, if you wanted to find the side B instead, it would be instead a squared plus c squared minus 2ac cos B. And then c squared would be a squared plus b squared minus 2ab cos C. So just a simple way to remember, if you want to find A, you basically have to use B and C. But when you want to find the angle, when you want to find the angle to be used, it's going to be basically the A again. So the easiest way to remember this is, usually to use cos rule, it will just be like one bunch on the opposite side. You know, so you want to find side A, you got to use side B, side C, and angle A, okay? So simple way to remember, because it's basically like ambiguous case. You know how we learn about non-included angle? In this case, is the included angle, because it's in between B and C. You know, it's in between B and C. So let's show some situations when you have to use cosine rule. So let's draw two triangles. Okay. Alright. So usually you would have to use, in the first case, you would have to use cosine rule when they give you one angle and then two sides. Alright? Because let's say you wanted to find this, right? But you can't use sine rule because you don't have these angles over here, right? You don't have these angles over here, so you can't use sine rule. Sine rule is out of options. So you would have to use cos rule and use the squared, right? But just keep in mind, every time you get the answer, you're going to get a squared, alright? So don't forget to square root it. Now the second situation is when they've given you only sides, alright? And then they ask for you to find one of these angles. It could be anyone. So this one's usually involving a lot of manipulation, but it's very, very obvious. Alright, so lastly, we're going to be looking at the formula to find the area of a triangle. So same thing, this can be written in multiple ways. So area triangle ABC would equal to, this is the base formula, right? 1/2 AB sin C. So basically, something like cosine rule, you would have to use two sides and their included angle. In this case, it will be C. So basically, you can actually change this into the form of 1/2 AC sin B instead, or you could even use 1/2 BC sin A. Alright, just remember, you want to use AC, you gotta use the included angle B. And then if you want to do BC, you gotta use the included angle A. AB, the included angle C. That's an easy way to remember how to use area of triangle ABC. But this is a very straightforward formula, just use it. Sometimes you would have to backtrack, you know, you'd have to backtrack instead. So that by itself involves a bit of algebraic equations and all. But another one that's actually taught in the textbook is something called Heron's law. Basically it's in the syllabus, but by right, you don't actually even need to use Heron's law, because basically the situation to use Heron's law is when the only thing given are the sides, as in angles aren't given. But by right, with the sides being given, you could use cosine rule to find the angle actually, and then straight away use the other area law. Because basically Heron's law is actually quite complicated. I'll show you right now. So basically, the first thing you need to find is S. So this is how it works. S equals A plus B plus C over 2, alright? And then the area of the triangle ABC is equal to square root, oh god, my square root's so ugly. Alright, straight line, then S times S minus A times S minus B times S minus C. Basically, it's a lot more multiplication. I mean, if you think about it, this is a faster method compared to having to use cosine rule and then having to find the area. So this is something good to keep in mind also, but I generally don't use this at all because I just prefer using cosine rule even more. But basically this formula is adding all the sides and dividing it by 2 to get the S, and then you just sub in the S all over in here and then subtracting B, A, B and C and then square rooting it to find the area. But yes, that's basically Heron's law. But honestly, I still prefer this first one, the area of the triangle one, because it's just easier to remember. And having two formulas to do one thing it kind of makes you confused, so it's better to just be better at the other one, yeah. Alright, so before I finish it off, let's go over some tips. Number 1, alright, solution of triangle is only used, alright, you only use it for when it's not a right angle triangle, alright? SOT, use only when not right angle triangle. Oh my god, I did not know that would give me an arrow. That's you. The things you learn, Ooh, okay. So when it's not a right angle triangle, alright, keep that in mind. Because when you have a right angle triangle, you can use the SOHCAHTOA, right? The sin is opposite over hypotenuse. You can use the SOHCAHTOA. It's way easier. And it's not a waste of time. Because sometimes using solution of triangle for a right angle triangle could actually give you a wrong answer. I've done it before. Maybe it was my own carelessness, but depending on SOHCAHTOA for right angle triangle is much easier, and using solution of triangle only for non-right angles is a better option. Alright, number 2 is to, we know about ambiguous case, right? So some questions will actually make you use a triangle that has an ambiguous case, and when you punch it in the calculator, you will actually get an obtuse angle. Alright, let me just draw it there. You will get an obtuse angle. Okay, you get an obtuse angle, but the answer is asking for an acute angle. Okay, it's asking for an acute angle. So basically, when you are in that situation, what you have to do is just subtract. Let's say this is x, right? We just do 180 minus x, alright? Because basically, this is like when you use it can happen to both cos or sine. You could get an answer that is an obtuse angle. So if you know that the triangle you are finding is actually an acute angle, just do 180 degrees minus x. Alright, x being the angle that you've got in the calculator. Alright, so this is when calculator is inaccurate, or in this case it is not what we want, right? Alright, so finally is to analyze the situation, because basically sometimes what happens to me when I do solution of triangle is that when I could have used sine rule, I use cosine rule instead, which made me use more time to answer the question. You need to be able to analyze these questions to use the fastest way possible. That's what AddMaths is. You want to do the fastest and easiest method to find an answer. So make sure you do that. Alright, thank you. Alright, thanks for watching, guys. Hope you enjoyed the series.